Hi students. In this lecture, I am going to discuss problems based on equilibrium of rigid body. Let us see first one. So earlier I have discussed question number 8, right? Let us see ninth one. A cubical block of mass m and edge slides down a rough inclined plane of inclination theta with a uniform velocity. The torque of the normal force on the block about its center has a magnitude. So this question is taken from Hetzi Verma. We can see how to start the problem. And this key point is the block moves down with a uniform velocity. So calculating torque of normal force about its center. Right, let us see how to start the problem. Let us make a diagram for the given data. Let us take an inclined plane. Inclined plane. Suppose angle is a theta. There is a cubical block which moves down with uniform velocity. Okay, so uniform velocity means on the cubical block net force equal to 0. Let us see now number of forces acting on the block. You can see normal reaction. At this contact, we can focus frictional force. It is now sliding down. Friction is now kinetic. Next, taking two components for weight, that is mg sine theta and normal to inclined plane mg cos theta. Okay, so next we have to focus normal reaction. Okay, is normal reaction passing through center or not? That we have to decide once. Let us see. Since condition is given uniform velocity net force 0, from that we can say along the incline net force must be 0. That means that frictional force is now kinetic, which must be balanced by, so this force should be balanced by mg sine theta. Okay, it is a kinetic friction because it is sliding down. Next, normal to incline, there is no net force, normal to incline. Therefore, normal reaction should balance mg cos theta. So up to here it is okay. Now we have to focus about torque. It has uniform velocity, net force 0. Next, it has only uniform velocity means there is no torque. There is no torque. That means net torque must be equal to 0. So now we have to find out. So we have to find out torque due to normal reaction about center of the block. Okay. Let us see carefully. Net torque is 0 because uniform velocity only sliding. Okay. So I'm taking now about center of the block net force, sorry, net torque equal to 0. Then see what happens. Because of weight mg, torque about center is 0. Next, because of frictional force about center, because of frictional force, it tries to rotate. It is anti-clockwise. See carefully, direction part. About center, because of friction, torque is anti-clockwise. but condition is it has uniform velocity. So there must be a torque due to some other force, which is a balancing torque due to frictional force. So I'm writing here torque due to frictional force is balanced by, already we have seen, because of gravity no torque, because gravitational force is passing through center of the block. That means the only possibility is now torque due to normal reaction should balance torque due to friction, and that torque must be clockwise because due to friction torque is anti-clockwise. Okay, that means normal reaction has to shift down the incline, then only about center it produces clockwise torque. Okay, therefore I can write here torque due to normal reaction, that modulus value is equal to, because of frictional force value how much, mg sin theta. So mg sin theta distance, we can say perpendicular distance from center, it is a by 2, so into a by 2. Okay, it is very simple and direct. Suppose in this problem if they ask how much distance normal reaction has shifted down the incline, suppose take it as x, then see what we can write here. So we know n equal to mg cos theta, mg cos theta into x, that is equal to mg sin theta into a by 2. mg cancels, x equal to a by 2 into tan. So by what distance, means if they ask by what distance normal reaction has shifted down the incline, it is a by 2 tan theta. Okay, let us see next problem. So answer is option D. Right. See 10th one. Two uniform rods of equal length but different masses are rigidly joined to form an L-shaped body, which is then pivoted as shown. If in equilibrium the body is in the shown configuration, the ratio, type mistake, it is the ratio capital M by small m will be. Okay, let us see how to start the problem. Condition is body is in equilibrium. So net force 0, net torque also 0. See the diagram given. Given rods of equal length. Take each one is with vertical. With vertical, they are making some angles. Given right one, it is 30. And remaining one is 60. Okay. And mass is smaller. And this is capital, right? So we have to find ratio m by m. Okay. Right. See what we can do. About point of suspension, take torque equation. So net torque must be equal to 0. Okay. So let me take here. It's weight mg vertically down. And its weight also, which is passing through center of the rod, is now down. Okay. Right. Now see the perpendicular distance. I should be careful while taking what is the perpendicular distance. Okay. This is the distance we have to calculate. So it is now mg into L by 2 because this weight is acting at center of mass. Distance is now L by 2. So this will be now L by 2 sine 60. L by 2 sine 60. That should be balanced by mg into L by 2 sine 30. Okay, G L by 2, G L by 2 gets cancelled. Cap by small m. Sine 60 root 3 by 2, and this is now 1 by 2. 2 gets cancelled. It is now root. Okay, so very simple and direct problem. Let us see next one. Let's see the question given. A right triangular plate ABC of mass m is free to rotate in the vertical plane about a fixed horizontal axis through A. It is supported by a string such that the side AB is horizontal. The reaction at the support A is, okay, this is again in equilibrium, right? Right triangular plate, mass M. Let us see how to find it. First make a diagram. This is now triangular plate. This is now string. Point B. It is now supported at A. Supported at A. Given this is N and this also N. Let us see now how to calculate that force from the support. So first focus at a free body diagram. So here tension T upwards, and here mg which is through centroid, right? Mg downwards, and here that reaction force. So take it as F. That F we have to calculate. Okay. So what we can do is, let us calculate tension by taking torque equation. So since it is in equilibrium, net force 0, net torque 0. So whenever net force is 0, net torque will be same about any point. So using that point, so I'm taking a torque equation about point A. Okay. So about point A torque, it must be 0. That implies because of tension torque T into L. So about point A, because of tension, torque will be anti-clockwise. Okay. And because of mg, about point A, torque will be clockwise. So they must have same magnitude. So mg into, this is now passing through centroid. So this distance will be equal to, from here to up to here, distance will be equal to L by 3, right? So L by 3. So tension T equal to mg by 3. Okay. Now write net force equal to 0. Net force 0 means F plus tension. Sum of these two should balance weight mg. Tension mg by 3. So F equal to mg minus tension. Tension is mg by 3. That is now 2 mg by 3. That is a force at the support. Okay. So very simple and direct one. So first we have taken torque equation and next we have taken the force equation, right? Okay, let's see next problem. This is a previous IIT problem asked in 2014 advance. In the figure, a ladder of mass m is shown leaning against a wall. It is in static equilibrium, making an angle theta with the horizontal flow. The coefficient of friction between the wall and the ladder is mu1, and that between the flow and the ladder is mu2. The normal reaction of the wall on the ladder is N1 and that of the floor is N2. If the ladder is about to slip, then see diagram. This is now diagram and given conditions which we have to verify now. Let us see how to start the problem. First of all, make the diagram given. So given a ladder which is leaning against a wall. Right. This angle is 1 theta. And we are given that normal reaction, right, from ground, that is N2. Normal reaction N2. From wall N1, its weight mg downwards. Rod is about to slip. About to slip means at this contact friction will be right side. I'm taking it as F2. Okay. When this is slipping like this point is moving down. The friction will be up. So first we have to guess directions for frictional forces. So frictional force at this contact must be opposed, and at this contact it must be right side. Okay. Okay. Now, since it is in equilibrium, net force is zero, net torque is zero. Okay. Right. Let us take both are rough surfaces. Then see possibility. Let me take horizontal as x-axis and vertically up as y-axis, positive y-axis. So if you consider net force along x-axis is 0, then see what we can write. Horizontally, how many forces are there? We can take, right, horizontally how many forces are acting. It is N1 horizontal, F2 also horizontal. So one condition, N1 should balance F2. Okay. Next, if we consider along vertical, Fy equal to 0, that implies along vertical, we can see F1. Since about to slip, what we can do is, in the place of F1, we can write it is mu1 N1. Okay, limiting friction F1 plus N2 should balance mg, right? Let me cross check. F1 upwards, mg downwards, n2 upwards. Okay, so it is mg. Right now, see what we can do. So here we have to calculate now n2, right? We have to calculate n2. So in the place of n1, see what I can write. F2 is nothing but mu2 into n, right? So now I am using that result in this equation in the place of n1, writing now mu2 n2. This becomes now mu1 mu2 n2 plus n2, that is equal to mg. So from this we get n2 value mg upon 1 plus mu1 mu2. Okay, right. Next, see what we can do. Let us see options once. Options given. So this is now matching with option C, right? Option C. It is correct. Now verify option D, mu1 0. If mu1 0, n2 equal to mg. If mu1 0, n2 equal to mg. So in this, what we can say is mu2 we cannot take 0 because if ground is smooth, then this cannot be in equilibrium, right? If ground is smooth, because of frictional force, it is upwards here. Normal reaction is now left side. If it is smooth, there is no force acting horizontally to balance that force. So mu2 cannot be 0. That is not possible. Okay. That's why no need to verify option B. Okay. That's why we are verifying option either A or it is now D, where mu1 equal to 0. Right. So n2 equal to mg. Next, see what we can do. Let us take a torque equation. Suppose this is point A. I am taking torque equation about point. So why only point A means it is a completely our choice because net force equal to 0. Therefore, net torque will be same about any point. If we choose point A because of N2, because of F2, torque will be 0. So calculation becomes now more simple. Okay. Since we have taken mu1 0, no friction here. Now torque is only because of N2 and mg. So torque due to N1 should balance torque due to gravity. Okay. Due to N1 into, we can see perpendicular distance. It will be, suppose this is A, this is B, and this is now C. So N1 into BC, right? And BC value, it is L sine theta. If rod length is L, it is L sine theta. That should be equal to mg into, it is L by 2 cos theta, right? It is L by 2 cos theta. So L gets cancelled. So N1 sine by cos tan, N1 tan theta, that is equal to mg by 2. So option D, right? So here why we are not verifying option B means it is not possible. Okay, equilibrium is not possible. So options are option C and option D. So these two are correct. So I hope you got a clarity.